All right, this video is going to be about the solar system, and we're going to start out with what is the solar system. The solar system is made up of one star, the sun, and everything that orbits it. Such as planets, asteroids, so on. Now, the size of the solar system, and we just watched a video on that. How accurate is this picture? And it turns out that it is not accurate. Okay, if the sun was this size, all of the planets even Jupiter would be too small to see. Okay, and Jupiter would be not on the page, it would be 30 feet away. And Pluto would be 2 football fields away. Okay. So why do they draw the solar system like this? Well, if they draw it like this, you can actually see it, okay? You can't fit this model on the page. It'd be 2 football fields big and the planets would be too small to see. So terrestrial versus Jovian planets, and the word terrestrial means like Earth. And they are small, rocky, high density, they have few moons, and they are close to the sun. All right. And there are 4 terrestrial planets. There is the Earth, Mercury, Venus, and Mars. Jovian means like Jupiter. Okay. These are big, gassy. We call them gas giants. Low density. They have many moons. And they are far from the sun. And the examples of those are Jupiter, Saturn, Uranus, and Neptune. So, objects in our solar system, we always think of the major planets. These are objects that are big enough that gravity makes them circular, and they have cleared out their orbits. Of other objects. And we have 8 of those. Okay, and it's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Venus, and Neptune. All right, then there are minor planets, and these are big enough that gravity makes them circular. But they don't clear out their orbits. And there are literally hundreds of these. And lots of them have names. Okay, and that's why we've decided that Pluto shouldn't be a planet, because if Pluto's a planet, then all of these hundreds of things also have to be planets, because they're really not any different than Pluto. Asteroids are small, usually rocky objects. Most orbit in the asteroid belt between Mars and Jupiter. So these wouldn't be round. When we say small, I mean they could still be a mile or two across, okay, or many miles across, okay, but they can also be as small as like a boulder just flying around in space. So here's an example. Most of them are in the asteroid belt. Meteors, meteorites, and meteoroids. And these are just 3 different words for the same thing. It depends on where they are. So I'm going to start out as a meteoroid. This is a small rocky object in space that will hit the Earth. But now it's still in space. A meteor is that same object not rocky. So now it is flying through the atmosphere and burning up. All right, and we call those shooting stars. Now, most of the smaller ones will completely burn up as they go through the atmosphere, but some are large enough that they make it to the ground. And when they make it to the ground, they are called meteorites. So rocky objects from space have made it to the meteorites. And craters are holes made when a big meteor has ground. And this particular picture here is a meteor crater in Arizona, and it's over a mile across. This down here is a parking lot, so it's very big. All right, and then here's a picture of the moon. Obviously, lots and lots of craters. And we've talked about this before. Okay, why are there more craters? This, which is more likely to be hit by a meteorite to the Earth or the Moon? And the answer is actually the Earth. It's bigger. So it's easier to hit a bigger thing, and it has more gravity. So it's bigger, so it's easier to hit it, and it has more gravity, so it's going to pull more in. So then why do we see more craters on the moon? Because craters on Earth are destroyed by erosion and plate tectonics. Okay. The whole surface of the Earth has been made over by the plates moving around, and that has destroyed any craters that were left behind millions of years ago. Comets. Comets are icy objects that are in orbits that bring them near the sun. By near the sun, we mean, somewhere around Mars, Earth, Venus, like that. They start out way, way far out, way past Pluto, but they have these long elliptical orbits that bring them near the sun. When they near the sun, the ice vaporizes and forms a tail of gas. Now, the tail gets pushed away from the sun by the solar wind. Which is a stream of particles that are flying out from the sun, and it pushes the tail away. So the tail always points away from the sun. When we look at the tail, we might think it looks like the way it's moving, like it's flying to the right, so the tail's behind it, but that's not really the case. So if I was to draw the tail on this comet right here, so I have this comet going around, and here's the sun. When it's far away, it's not going to have much of a tail at all, or maybe no tail. Okay, and as it gets closer, so maybe we'll just draw a little bitty tail over here. All right. And then as it gets closer, its tail okay, is going to get bigger, and it's always going to point away from the sun. All right, let's go here, point away from the sun. And then as it gets away from the sun, it's going to get smaller again. So then maybe out here, it's not going to have a tail at all. Okay. All right, and then the Oort cloud and the Kuiper belt. These are regions far from the sun. The Kuiper belt. Starts around Pluto and extends much farther out. And then the Oort cloud is on the spherical region. Far beyond the orbit of Pluto. And both contain many icy objects. Okay, so all those minor planets we're talking about that are out like Pluto, they're going to be out here in the Kuiper belt and in the Oort cloud. And so they can have things that are as big as Pluto all the way down to pretty small objects. And they think this is where the comets come from. If two of these icy objects get close to each other, one's gravity might throw the other one in towards the solar system. And as it gets closer and closer to the sun, it starts to form a tail, and that's where comets come from.